What's up guys, this is Youngno. Let's solve this question. So on this question, we have a quadratic function whose graph is a parabola. The graph of it has vertex point at 2, 5. But the thing is, we don't know whether the parabola is supposed to open upward or downward. We just know where the vertex is. H of 4 equals 7. That means that parabola has to pass through the point 4, 7. And we're looking for another solution other than 4 to the equation h of x equals 7. So we're looking for some number resulting in 7 for y value. There could be an algebraic way or a graphical way to solve this question. I think graphical way might be easier, so let's give it a try first. Let me just draw an xy plane here. Then the vertex is supposed to be located at 2, 5 here. And the parabola is supposed to pass through the point here, 4, 7. Oh, so now we know that the parabola is supposed to open upward. Because it has vertex point here, it's either opens downward or upward. But we have additional point the parabola is supposed to pass through. So now we are pretty confident that this parabola is supposed to open upward. The thing is, every single parabola has an axis of symmetry. It's an imaginary vertical line x equal 2 here. So that means distance from that axis of symmetry, since this point here, it's 2, 7. The distance between these 2 points is just 2. So that means if you go to the left by the same distance 2, we reach here, which is located at 0, 7 by the symmetry of the parabola. Ooh, we just found the solution. 4, 7 is on the parabola, which means h of 4 equals 7. And we just figured out 0, 7 is another point on the parabola. That means h of 0 has to be equal to 7. So we just found another x value resulting in 7 for y value. So we're done. Bravo is the answer. So that was a graphical approach to this question. Then I think this question can be solved in an algebraic way, but I think it's harder. That's why I did the graphical one first. But let me give it a try. So since we know where the vertex point is, you can just start with a vertex form of that function, having vertex at 2, 5. But still, we don't know the value of quadratic coefficient a. But the thing is, we have one point on the parabola. So that means once you plug 4 here, it's supposed to be equal to 7. So a times 4 minus 2 is 2. 2 squared is 4. So this is supposed to be equal to 7. So 4a equal 2. A is 1/2. So we found the complete function, quadratic function of h. This is it. And what we're looking for here is we want the function value to be equal to 7. So we're now supposed to solve this equation here. Let's do that. Let's move 5 to the other side. Then you have 2. Why don't we just multiply 2 to both sides to get rid of that 1/2? Then you have 4. Why don't we just take the square root? Square root of 4 is 2, but be careful whenever you're taking square root, you might have 2 options. So put the plus and minus sign. So we found the x. Once you plus 2 to both sides, you have 2 plus minus 2. So with the plus sign, you're getting 4. And with the negative sign, 2 minus 2, that's 0. So we just found 2 possible solutions to the given equation here. But we already know that number 4 is a solution. So we just found another one, which is 0. So answer choice Bravo is the correct one. But I guess graphical approach is way easier to solve this question. So remember that whenever you're solving some questions, Algebraic way might be easier for some questions, and graphical approach might be easier for some other. So you have to decide it. So be flexible. Okay, see you on the next question.